Hi, my name is Craig Harris, and I'm the Scrum Master for this week, and I'll be presenting the progress report number 6 for the Space Invaders 8080 project. So what went well this week? We've got the game running with controls, video, and sound. We've made some progress with packaging an executable to run on Windows machines. Testing still needs to be done with newer versions of the project for Windows, Linux, and Mac. What did not go well, we've been running into build issues with STL2 on GitHub. This is going to be one of our main debugging goals for the next sprint. We also realized yesterday that a fresh clone from GitHub would not build due to missing certain STL2 dependencies. For some reason, it was working for Nick, Damien, and myself with our already cloned repos that we've had for a while, but Julie, getting a fresh clone, was unable to build and run the game in order to test controls. This put a block on control progress and in turn blocked some progress on sound. To address this, we fixed the STL2 building problem locally for Julie, but it still fails on GitHub. It does work if you pull a fresh clone right now. So progress this week, Julie got 90% there with a first attempt at controls, but again wasn't testing it because the game wasn't running locally on her machine. The fully working version has been merged into Nick's working branch, which I will demo later. Damien got the display colorized and rotated. He's also been working on packaging up the project for more portability and final submission. He has so far tested an older version of the project on several Windows machines and Linux running through Wine. He also got all the final deliverable templates, requirements, and schedule together so we know what needs to happen next. I implemented timing restraints for Windows, Mac, and Linux with help from Nick to get the Linux version working so the game doesn't run too fast on powerful computers. I got our opcode tests running with the STL2 package in the repo on GitHub, but this has since been superseded by Nick's contributions. I added a debugging feature that prints a description of which section of code the emulator is currently in. These descriptions were taken from the computerarchaeology.com. I implemented a feature to allow resolution window scaling by integer multiples. Nick worked to organize our main.c by pulling out relevant functions into discrete files. He's been continuously making improvements to the CMake and GitHub workflow. Sound is 99% working with one small bug currently. All his contributions are still in a separate branch since we haven't gotten sound quite working or GitHub workflow nailed down. This has been where we've been merging some of our latest changes since the game runs fine locally. A PR was made only to be able to link it here. For upcoming work, there is one small bug in sound that I mentioned. The fire sound is repeated as long as the shot is on screen, and I'm sure Nick's going to fix that quickly. The final tasks have not been doled out, and many of them will be sort of group efforts. These include playtesting and finding bugs, and then consequently fixing those bugs, packaging up the project for Mac, Windows, and Linux OSs, code refactoring for readability, and possibly implementing some small stretch goals, including alternate colors, controls, and/or sound bites. We would need to make some sort of interface to modify these options. Whether that's going to be a GUI or just keyboard input is to be determined. As for blockers, Julie is not blocked at this time, but she was up until yesterday since she couldn't run the game, meaning she couldn't test controls. There are no individual blockers for Damien, Nick, or myself at this point. The big blocker really is just that we're having trouble getting GitHub to build the project and run the tests. The action item to remove this blocker is to do some research and debug. For some notable acts of teamwork, Damien made sure we're all on track with the deliverables by outlining the timeline, templates, and requirements. I walked Julie through how controls are handled and how to get the game emulation to actually utilize them. Nick made some big contributions to code organizations, CMake, and the GitHub workflow. Okay, now I'm going to do a code demo. Okay, so this is our main file from Nick's working branch, which again is where we've kind of been putting everything over the past few days, a lot of our recent contributions. So we first get the game state, load the ROM, we initialize the timers, the SDL2, Windows, and Surface, and the audio. And this is the main loop where we handle any interrupts and run the emulation, and then we run one pass of that, and then we check, we pull any events from SDL. And this could be quitting the window or getting a keyboard input for controls. And so when there is a keyboard control, and this is Julie's contribution here, basically, for example, if I hit the C key, it modifies the 1 port to the appropriate bit field. When I press it down and when I press it up, it's the opposite. That's controls, and if we go into the handle interrupts and emulate, we've got some debugging stuff here. We pulled out the in and out emulate codes so that gets handled by these machine in and machine out functions. And that's essentially a switch case. So for example, in 1 or in 2, which the game is constantly running, it just takes whatever is on port 1 or 2 and puts it on the A register. These are not used by the game and we can get rid of them. And for out, that out 3 would tell the audio system to play a certain audio byte. And then if it's not an in or an out, it does the standard emulate 8080. And this is where the screen gets updated. So it gets updated, the screen gets updated twice every frame. First the top half and then the bottom half of the screen. So basically, we did the math to figure out how many cycles per frame are needed based on 60 frames per second and the 2 megahertz of the 8080 processor. And we're counting how many cycles elapse. So if we get here and we get here too fast, then it waits for 1/120th, and that's because it's doing the 2 screen writes. It's sending 2 interrupts. If we've met all of that, then we write whatever is in memory, in the video memory, onto the SDL surface. And we do the same thing for the second half of the screen, 1/120th of a frame, or 1/120th of a second later. So I'll go ahead and run the game, and you should hear sounds after the demo. So the demo runs without any sounds. And you'll see it's running at normal speed. This is my fairly nice computer. If we didn't have the timing, it runs way too fast. And so I can hit the C button and add some credits. Once you have 2, you can play as 1 or 2 players. And you'll see when I hit 2, it should go down by 2. Yep, now we're at credit 11. Now we should hear some sounds. And there's the shoot button going too many times, I think. I'll let you hear the... There we go. All right, and that's it. Thank you very much.